Okay, so I took problems 35, 36, 37, and 38 and moved them to a separate document and put graphs on there so that I could graph them on the video, okay? So for problem 35, it says, is triangle TVS scaling, isosceles, or equilateral? And they give you these vertices. So it's going to be helpful for us to graph this. So let's do that. Switch to blue. Okay. So it says that point T is at 1, 1. It says that point V is at 9 and 2. Make sure you label your points. And it says that S is at 5 and 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. All right. Connect your dots as best you can. In-person people, there are some rulers on the front table. If you want to grab them, you're welcome to. Sorry, that's not S. That's S. Okay. All right. So once you have it graphed, we are going to look at some slope triangles. We're going to look at the slopes of these figures so that we can find the actual lengths of them, because we're going to need to be able to compare the lengths in order to find out if the sides are congruent. So we need the slope, make a slope triangle from T to S, which is a right triangle where the legs of the right triangle are the slope. So the rise from T to S, 1, 2, 3, 4, 5, 6, 7. The rise is 7. And the run from T to S, 1, 2, 3, 4. Okay. All right, and SV, we need to make a slope triangle from S to V. Okay, from S to V. Okay, for the slope triangle, the length of the rise, 1, 2, 3, 4, 5, 6 units. Now, if we're talking about slope, that of course would be -6 since it's going down. But we're just talking about the lengths of the legs of a slope triangle. And then the run is 1, 2, 3, 4. Okay, and if we make a slope triangle for TV, you can see the rise is only 1. And the run is, I believe, 8. Yeah, that's right. Okay, so we had talked before about the fact that if the numbers are different in your slope triangles, then the sides will not be congruent. But looking at these, we should probably go ahead and check those with the Pythagorean theorem just to make sure. So for TS, we do Pythagorean theorem. Then we'll have 7 squared plus 4 squared equals TS squared. Okay, so simplifying that, 7 squared is 49. 4 squared is 16. Equals TS squared. 49 plus 16 is 65 equals TS squared. So taking the square root of both sides tells us that TS equals the square root of 65. My tablet is going out on me. Okay? So we know that TS is the square root of 65. Okay? So let's do the same thing for SV. We've got 4 squared plus 6 squared. So what we're looking for is to see if any of these sides squared and added together, sorry, plus, are going to be 65. So 4 squared plus 6 squared. Well, 4 squared is 16, and 6 squared is 36. 16 plus 36 is 52. That's not 65. So that's not going to be the same as TS. Okay? So let's look at TV. For TV, we've got legs that are 1 and 8. So 1 squared plus 8 squared. 1 squared is 1, and 8 squared is 64. So, this one will be. So when you square the legs and add them together, you get 65. When you take the square root of both sides, we found out that TV is also the square root of 65. So we actually do have 2 congruent sides here. Sometimes it's worth doing the math, and working your way through the Pythagorean theorem. Okay? All right. So we did find out, changing colors, that we do have two congruent sides on 35. We found out that TS is actually congruent to TV. So we do have an isosceles triangle here. Okay? All right. On number 36, this is a quadrilateral, has those vertices. So again, we want to go ahead and graph this. And says what special quadrilateral is formed by connecting these vertices. So it says we have a point at 5 and 3. 1, 2, 3, 4, 5, and 3. It says we have a point at 5 and negative 1. It says we have a point at negative 1 and 3. And it says we have a point at negative 1 and negative 1. If you graph that and connect those dots, you should come out with a figure that has two perfectly vertical lines and two perfectly horizontal lines. So hopefully you can see that those are in fact opposite sides, congruent and parallel. And since two of them are perfectly vertical and two perfectly horizontal, then we also have four right angles. What kind of figure are we looking at? That is in fact a rectangle. Good. Okay, type that out here. Okay, good. Looking at 37, this is that isosceles trapezoid ABCD has legs AB and CD and base BC. And it gives you equations for all three of those. Well, if it's an isosceles trapezoid, what do we know about the legs? Good, the legs are congruent. So really, we just need to make sure that we know that AB equals CD. They've given us information here that we don't need as a distractor. So we don't need BC. We don't need that equation that says 4x minus 7. All we need to do is set the other two equations equal to each other and solve for y. So if AB equals CD, then that tells us that 6y minus 6 equals 7y minus 12. I'm going to subtract 6y from both sides. So the left side will leave me with negative 6. On the right side will leave me with y minus 12. So my last step then would be to add 12 to both sides. Oops, add 12 to both sides. So I end up with y equals 6. Okay. One more. And then I have a surprise for y'all. Okay. On 38, it says prove that quadrilateral ABCD, and it gives you those coordinates, is a parallelogram. Well, the most basic quality of a parallelogram is that it has two pairs of opposite parallel sides. So we are going to need to compare the slopes. So let's get this thing graphed. Okay. So we've got A at negative 3 and negative 4. Make sure that you're labeling these as you go. Okay. You've got B at negative 1 and 0. So it's on the x-axis. Okay. You've got C at 5 and 0. 1, 2, 3, 4, 5. And you've got D at 1, 2, 3 and negative 1, 2, 3, 4. Okay, so once you've got this graphed, connect your dots. We can see that BC and AD are definitely parallel because they're perfectly horizontal lines. Go ahead and put parallel marks on those. So all we need to do then is count some boxes and calculate the slopes of AB and CD. Okay, so my rise from A to B, 1, 2, 3, 4, and my run is 2. Okay, then my rise from C to D also 4, and my run also 2. So I can see that those slopes are also equal, so those sides are also parallel. So yes, we do in fact have a parallelogram here. So yes, parallelogram. Okay. So the surprise is I'm not going to go through here and tell you which of these 25 of these 38 questions are actually on the exam. You want to know that? Yes. I thought that might be helpful. Okay. Okay, now you still have to complete all 38 problems and show all of your work to get the extra credit. But go ahead and circle the ones that are on the test so you know which ones to study harder than the other ones. Listen for the 25 problems that are actually on the test. But you still must complete all 38 problems and show all work to get the 10 extra credit points. Y'all ready? First page, you ready? First page, we've got numbers 2, 3, 5, 6, and 7. Page 2, numbers 9 and 12. Page 3, number 16. Page 4, numbers 17, 19, and 20. Page 5, number 23. Page 6, all 5 of them, 24, 25, 26, 27, and 28. Page 7, numbers 29, 31, and 32. And page 8, all but one of these, 33, 34, 35, 36, and 38. Now go back and count the ones you circled and make sure you got 25 of those circled.